Welcome to this very last session it is, right? Before the keynote, the last session of SpringOne. I hope you enjoyed the conference so far. Yeah, welcome to the session. I'm kind of surprised to see so many people attending here. Who of you has been to my DDD and REST session on Tuesday? Around about half of the audience. The reason I ask is that I might refer to that session a couple of times within that talk here. So even for those ones that haven't seen it, there will be a recording online so that you can refer to details of that. I don't think you'd definitely be able to follow here, but I might just point you in some places to that presentation because it might just give you a bit more background on why we do things the way we do them in Spring Data REST. Who of you is using Spring Data REST already? Okay, the ones that didn't raise their hands are the brave ones because they go to an advanced talk or something they've never used before, which is interesting, but okay, that's fine with me. My name is Oliver Gierke. I work for Pivotal. I'm leading the Spring Data projects, which basically means that everything that's not inside the core framework, but Spring Data related or data related in general, is crossing my desk at one point in time or another. Yeah, so what's Spring Data REST? It's one of the odd ones out in the Spring Data umbrella project. So Spring Data in general is basically data access APIs for your Spring application, makes it easy to work with different data stores, exposes a repository programming model, and that allows you to just easily interact with those stores. So most of the modules in the Spring Data world are store-specific modules, like the one for MongoDB, the one for JPA, for Neo4j, what have you. Spring Data REST is the odd one out, as I said already, because it's not interacting with any store, but actually trying to leverage the code that you have in your code base, the domain model, and tries to derive, just as the Spring Data repositories sometimes derive queries from a method name, for example, as you've probably seen before. We try to derive a decent default for a set of HTTP resources that we expose so that you don't have to write a lot of boilerplate code. So if you're just casually looking at the project and you just see, okay, you put your domain classes here and you put your repositories there, and then you flip on Spring Data REST, and then you get all these nice Spring JSON endpoints that we've seen a bit, or HTTP resources sending out JSON, then some people just get to the impression that, okay, we're basically just exposing a database to the web, right? And I'd argue that's totally not what we do, because the most important aspect to an application using Spring Data REST is actually your domain model. And there's a lot of knowledge that's in your domain model that actually decides, or the quality of your domain model to some degree decides in how far Spring Data REST can do the right things for you, right? That's why I put this decent in here. You can, of course, use just some arbitrary tool to generate entities, JPA entities from a database, and then you end up with a giant sea of entities, everything connected to everything. And then you throw your repositories at them, have one repository per entity, and then wonder why Spring Data REST is not really working for you, and then start trying to customize that. If you're here for that part and thinking that's what I thought of advanced Spring Data REST, that's not the case. But I get to that in a second. So a decent domain model is the fundamental a requirement for Spring Data REST to work. More on that, and the way, when I say domain model, I basically refer to DDD, and that's the point where I wanted to refer to the other talk. So in case you haven't seen that, what the aspects are, what the crucial things are to have here, feel free to watch the recording of the other talk. So what we put on top of that, and that basically then makes up Spring Data REST, or what it actually does, is basically an implementation of certain patterns that you can find. We didn't really invent anything here. You can find those patterns in various books. There's RESTful web APIs. There is a couple of O'Reilly books. There is even one that's written in a very patterns-like fashion. And we basically just took a look at those patterns and actually wondered how do they actually relate to, like, if you have these repositories and have this domain model, which patterns do make sense, right? Because when people identify these patterns by saying, okay, here's this context, here's this problem, here's a solution for that, right? And we basically providing an implementation of some of those patterns. Just like you can sort of relate that to the way that Spring Integration implements the patterns of the Enterprise Integration Patterns book. I mean, there's one book, there's one implementation, there's a slightly different relationship, but conceptually, it's sort of the same. So let's say you start with that and you have a, let's say, better domain model, not just like arbitrary entities, and you haven't thought about anything really. And you flip on Spring Data REST, it will actually create some HTTP resources for you that your clients could use. But the point actually is that we're just trying to make the simple things less cumbersome. We try to take away the boilerplate out of the simple interactions, right? There are going to be like entities that you want to create, right? So you probably have a collection resource and an item resource, and you post to the collection resource, say, /products, and to create a new product or register a new product with the system. However, usually your domain or the software you write is not really only about like CRUDing or CRUD operations on some entities. You might think about them as such, but usually if you like speak with business experts, there are more interesting things to consider and more interesting things that you might want to expose explicitly. Again, something that I discussed in very detail in the other talk, to your clients, right? So what we want to do, and basically only if you add that additional stuff, you get to a decent REST API. I definitely argue, and I'd even go so far as saying, okay, the most advanced usage of Spring Data REST is to not use it. That's probably a bit weird statement in the first place, but if you can get away from all of these CRUD operations or understanding like your HTTP API as a CRUD API, then you actually get to a more decent API implementation. So ultimately, our goal is for you to focus on these two aspects by providing you the other two, because they are the ones that will make your API great, right? So we take away the pain out of the boilerplate, to give you more time and more time to think about exactly these two things. That's just like want to set the context slightly, because I often hear that, well, it's just like flipping tables by 90 degrees and call this JSON and then be done with it. That's not it. So the rest of the presentation, I'd basically like to spend discussing or showing you a couple of the Spring Data examples. And I mean, if you have skimmed through them already, you might find some things familiar, especially with the latter example, the Spring RESTbox one. There will be things in there that you haven't not looked into detail about it, but I probably go ahead and want to discuss these samples also in the context of what I just basically said. Okay, where are the aspects where we basically plug the custom operations, and how do we actually get the custom API parts to work with Spring Data REST, and what's the best way to actually do that, get that integrated. All right. Let's start with just a tiny example for everyone to basically be on the same page what Spring Data REST does. I don't want to overdo that, because if you've used it, you've seen that like 1,000 times before. So what I have here, it's great that Eclipse doesn't remember the font size setting for other files. So the example I have here is basically I found a CSV file of Starbucks locations of entire North America, somewhere on the web, 11 megabytes or something. And I thought, how much code does it take to actually build a geospatial API that allows me to search for these stores in my, like around me basically, right? So in my area. So I choose MongoDB here because it has the ability to trigger geospatial APIs or geospatial queries. I can do that very easily. I'm using Lombok here to just like define a tiny domain model here. Just have this store in here that has addresses. The addresses have like some textual properties here, and that's the important point. No pun intended. The location that we put a geospatial index on, right? So that's basically it. That's not really like the MongoDB and Lombok part is not that important. What might be important though is that MongoDB is actually or any document store is kind of a nice store to build APIs upon, because it knows the basically the document is very close to the concept of an aggregate in the DDD world. So it makes users of the database think about, where are my aggregate boundaries, right? Where are my document boundaries? And there are differences in relationships between, let's say, the store and the address, because they're contained within each other, and like the store and maybe something else, which is a different kind of relationship. But again, I've discussed that in the other talk in detail. So what we add on top of that, and then we're probably about to finish that part already. Again, zoom in here and remove that slightly. So what we have here is a repository. It's a paging and sorting repository. So it allows clients to just not request all the stores, but let's say 20 at a time. And there's also some CradySL stuff going on here. But the important bit here is that we add a query method. In this case, that query method is just, or the query for that method is just derived from the method name. So we basically create a MongoDB query that issues a near query to find all the stores that have a certain distance from a given point. And we want to consume those all in a paginated fashion as well. I add some Spring Data specifics here, Spring Data REST specifics here. I name that. There will be a resource for that, and the name of the resource will be by location. So it's something so that the clients can find it. By default, it would have been the method name, which is something that rather looks ugly in the response. But alrighty, so let's see what we get. So if we run this thing, I've already done that in the background. There is, in this case, an API endpoint. Is that readable? Should be. Is it? Yeah. Okay. So we just find it in the root API endpoint. There is like a list of links basically. One of them is a profile link, well-defined, or that's not something we came up with, but it's a well-defined link relation actually that points to some metadata. I might mention that or go into detail of that in a second. But by the virtue of the fact that we had a stores repository or store repository, we now have a link relation called stores, and that points to a resource that will sort of serve our stores, right? So if I go here, then I get a response, and you see in here, there's all kinds of, it just like picks the random first 20. There's no particular order defined so far. And you see there are like 11,000 total elements in that collection basically, and we add the necessary metadata and additional links, hypermedia elements to actually navigate that pagination, that pageable collection. So as you see here, we already have this kind of, one more thing, maybe you could refer to an individual store to complete that. But that's not found. Awesome. Probably something going wrong here. Anyway, you see that what we do is there's a certain patterns that are implemented. Let's say, okay, pagination. How do you pagination in a REST world? Yeah, you basically just like serve parts of the entire collection and then have these well-defined link relations that the clients can use to navigate through that collection. So that's what it does out of the box. Of course, things get more complicated if you have like aggregates that point to each other, and we get into that in a second. But I think the point that I wanted to get at, the final one, is basically let you see the search resource. Do you remember the query method that we had in the repository? It's just like exposed here, and it's named by location. That's the customization here. You have a couple of parameters that that thing takes, and there should be a search, find by, yada yada yada, that one. So if we now go ahead and expand that URI template by using the parameters here and issue a request, we actually get just the query result, right? So effectively, what we've done is we created two domain classes, making up an aggregate, the store aggregate, because our domain is that simple in this case. We added a repository interface. We added one method to that interface. We enabled Spring Data REST, and we get a geospatial API, right? So I'd argue that's pretty simple. That's by far not sufficient. If you really want to expose that to a client, you probably want to add security and stuff like that. But why would you spend any more minute on implementing stuff like that if you just can get it this way, right? All right. So that's just for the casual watcher to find out, okay, what Spring Data REST does. So what's the first thing that might be something that's, oh yeah, we can probably stay in the ID right away, but that's not completely trivial, or that's maybe more advanced even. The way Spring Data REST fundamentally works is it looks at your domain model. It tries to identify aggregates, and that's probably the first question. Okay, how are aggregates defined in a domain model? Because JPA or most of the persistence mechanisms don't really know about the concepts of an aggregate. With the Spring Data REST repositories, we can actually, or the fundamental rule of thumb is, if you have a repository for an entity, it's basically interpreted as an aggregate root, which means we will create these collection item resources for you. But if you look at an example here, I mean, that's totally fine by default. I guess it just works for people. However, it causes the representations that are created to end up in a very special shape. Let me show you just that example, because that might just make the problem obvious, right? So let's bootstrap that. That's a slightly different or slightly more complex example. We have sort of an e-commerce application. We have a catalog that contains products. We have customers that hopefully buy some of the products. And we have orders represented. That orders contain line items which point to the product, right? And we have the order. The order is placed by a customer, of course. So that's working. Let's see. I think that's 80/80 for now. Right. So there's a couple of things here. Let's have a look at the customers first. Whoop. /customers. So there's exactly one. The customer has again a complex address object in it. Complex, I mean, it's 4 nested properties, but it's not just a plain value, right? It has a customer number as something special, so not a database ID. I've just used a UUID here, but imagine you have some weird business logic that defines how customer numbers are created in the first place, and they are actually used in here. There's an enum property in here, what have you. So that view and that the scope of the representation of that particular customer, if I can go to the individual one to avoid it looks a bit simpler. There's certain links in here. The self link should be self-explanatory. So it's just pointing to itself. There's a customer link again that basically it's just using the item relation, the name of the relationship basically, to express that, okay, that customer that we can apply a projection to that customer. What does that projection even do or mean? So the structure of that document is basically it's sort of a one-to-one representation of the domain object, which usually causes some criticism with the project in the first place, because people say, oh, then I tie my representation to my domain model, and that's a bad thing to do. And I say, okay, using a DTO that just copies every field of the domain object is yet another bad thing to do. So there's no right or wrong here. The point is that what we use here, you see we add some customizations because we sort of extract links and add links to the representation, but you still are under control of the way that JSON actually looks by just adding Jackson customizations. I'll show you some of them later on when we look into REST bugs. But these projections, or the way that JSON looks, can be customized through the means that your JSON library actually exposes. In this case, it's Jackson. So there is a mapping step going on, and no, I don't necessarily need DTOs for that. Right? All right. Still, even if we can customize, we could go ahead and customize the address or write a custom serializer for the address object, but sometimes we just need, let's say, a more compact representation of that customer, and we don't want to conditionally or have that implemented in a custom serializer. And Spring Data REST exposes a concept called projections. That's where that thing was already heading for. So we can go ahead and do something like this. I call this, it's called customer excerpt. So we basically define an interface that just includes all the properties that we want to expose. Let's say we want to only get the first name and the last name, and we want to get a slightly simpler representation of the address. So we can use an add value annotation with a spell expression in this case that gets access to the actual target object, to the customer, and then can do anything about it. So what I'm doing here basically is just I use the address and call to string on it because that just works. But I could also go ahead and do more sophisticated things by referring to other Spring Beans and then call my method and hand the target to it, right? So I could even have more complicated business logic calculating additional representations or structures that I then want to serialize. That would work as well. So we basically just annotate that thing, give it a name, and that causes that projection parameter to appear on the resource, because that means we can go ahead and say projection equals excerpt. And then we sort of get that thing reduced to only the address, like the address in that format that I represented, and first name and last name, right? So you can, for each of your entities, you can go ahead and even define multiple of these projections to cater the different clients' needs that want to see different things. Maybe it's just the same client asking for different granularities in certain or in different situations. Right. That's just like it. So the question is, okay, when do we actually use that, right? Or so is it just on? In this case, we're basically using it on request, right? So the client has to decide whether it wants to see the projection. However, these things come in handy in other cases. And to understand that, let's go back to the root endpoint. I think we should have something like orders, right? Where we see let's go to the first order, because then we just get rid of that embedded thing here. So the order, as I said, contains a set of line items. You see that? There's this items array in there, and that item in turn basically points to a product, right? And the order was placed by a customer, and we also have a link for the customer in here, right? So at this point, it's probably worth reiterating on the aggregate and versus entity thing here, right? So all the relationships that basically point out of the aggregate being the order plus the line items, is represented as a link, because like if we just included the customer in here and included the product here, we would basically just like naturally explode like the document. And even worse, while that might be sort of okay for the GET requests, it fundamentally raises the question, what do you do on PUT requests, right? Because you're basically pulling in the information of another aggregate, and then you want to put the order, and let's say someone accidentally tweaked the name of the customer. Is that something that's even like, is it even wanted, right? Is that even a valid thing to do? So SpringData REST basically looks at, okay, all the link or the relationships to other aggregate routes are replaced by a link to a dedicated resource, right? That's managing that thing. So we basically shape the relationships so that it works naturally for manipulating or non-idempotent requests, so for PUT requests, for POST requests, what have you. However, that raises the question that, let's say you have a master detail view in your client, and you want to show a list of orders, and you have all the orders listed, you probably want to show the name of the customer, right? So with that design here, you'd basically go ahead and issue one request for the list of orders, and then for each element in there, you'd have to issue another request to look at the customer, which is basically the n+1 selects problem in the OR world, or Object Relational Mapping world, translated into HTTP, which sort of makes that thing even worse. So what to do about it? You can elevate one of the projections that you have defined for your domain types and register that as a so-called excerpt projection. And that step basically, or what it fundamentally expresses is that, dear SpringData REST, whenever you render a link pointing to a customer, be sure to include that projection as a kind of preview in that thing that the link is coming from. That's quite a mouthful. But it basically just does the following. It adds, and that's the part up here that wasn't there before, it adds this underscore embedded. That's just basically a feature of the media type that we use, the HAL. It adds an embedded clause, basically using that projection. You see that are the same fields that we had used when we explicitly requested that projection before on the customer side of things, so that the client can now basically relate to, there is this customer thing that's being linked to, that's living over there, but by the way, for the same key, we find that preview here. So you can implement the clients in a way that, and like especially HAL clients do that quite often. If they're looking for some information of the order, in this case, let's say the name of the customer, right? They look at, let's say, underscore embedded, customer first name or customer last name. Are these fields available in the JSON? If they are, just use them from here. If not, resolve that link and then find like first name and last name in there. And if you program a client like this, it will be capable to deal with the non-excerpt projected representation, just as it will with that one, and it would just like not do any additional requests to find that information. There's the talk I was especially referring for is look up John Moore, hypermedia APIs. Something on, it's quite dated already, I mean dated in terms of old. He has basically a client that he doesn't recompile, and he changes the structure of the server-side representation, and by that just optimizes the way the client actually interacts with the server. Pretty cool stuff. All right, one question.
Projections cross-domain, or they have to be within the domain?
The question is, the projections, do they have to be within the domain or cross-domain? I'm not entirely sure what you mean by domain in this case. So, I mean, whatever you put into this class, in this case, get first name has to be, it's basically a property lookup on the customer class. So there has to be an equivalent of the backing object here. So you basically
Your orders, are they part of your customer domain, or are they outside of your customer domain?
the question is are the orders part of the customer domain, or are they separate? Again, I'm kind of wondering what you're referring to with domain. Is it like bounded context or something more like that?
Is it like if it's, let's say it's a microservice?
Yeah. Okay. Okay.
Is a microservice and orders is another microservice.
I see.
How
I see.
do they relate to
Okay.
each other?
Yeah. So the point here is that this works because, of course, we serve the customer and the order representations from the same system. However, fundamentally, like the idea of using hypermedia to point to other things actually allows you to, let's say, if we take that thing here, we're basically pointing to the same application, right? Or even like, in this case, it's a nested resource, because that's managing the relationship between the order and the customer. However, if the client uses hypermedia properly, it would just like follow that link, no matter where that points to. And if you later move out the entire customer management system to another microservice, all you need to do is make the order system aware of where that other resource lives, right? Through some, let's say, service discovery, and then hypermedia traversals on that service, and then just like the client would still go ahead and just use the link, and then but send the request to another service without it even noticing. So that's kind of like one of the benefits you basically get from developing a system like that. All right, so we've got to hurry up a bit. So I got that. So basically, the projections are already available as like you can explicitly request them. You can have excerpt projections. Sorry, to manage or to get or avoid this n+1 selects problem here. The other aspect, the one aspect that we haven't covered yet, but that we're actually working on, is to give you as a developer control over the projection selection, and that basically means you could have like 3 interfaces that extend from each other, the first interface only exposing 3 properties, the second interface exposing 6 properties, and the next one basically 10, and then let's say, due to security reason, like depending on who is actually issuing the call, returning a different representation, or just using a different projection, right? So there's stuff planned to be added, but that's not yet there yet. So the 2 other things I'd like to show you quickly on that example. One is that let's go back to the customers. Customers 1. You see that we have this customer number in here, right? And maybe for some weird reasons, because we built this new API and it's all hypermedia driven, but we have some like rogue client that's like still lying around that's has been used to, or that used to manipulate or create the URIs it wants to query itself, right? So a requirement for that system might be that we need, right now, you see we're using the database identifier in the URI. So it's basically customers 1 here. But to cater the needs of some arbitrary client, we actually might want to use the customer number in the URI, right? It's actually not something I'd recommend to do, but we had customers asking for that, unfortunately. And there's some API as basically configuration, where you can customize the lookup. Where you can customize the lookup of the entity, and that's a 2-step process actually. So what we basically say here is that we want to customize the entity lookup for the customer repository. So by default, like find1 is used, and we try to find the identifier property of the entity, and then just make up our URI structure. But if you want to customize that, you have to do 2 things. The first thing is you have on the entity, you have to tell us which property or which method we are supposed to call to find the thing that makes up the part of the URI. And on the way back, you have to give us a repository method that basically translates back from that customer number to the customer entity. So you're basically exchanging that. And I think it's kind of easy because you just like hand the method handles in here. Yet another example, I think, if you ever happen to meet Brian Guts, have him a beer, because Spring Data REST is entirely Java 1.6 based, and we're still able to write code that looks as concise in Java 8. That's, I mean, you don't want to see the implementation internals because that's like generics kung fu beyond repair. But it's been like once again, it's been like one of the eye openers, like to see, oh, I can write this code and then it would look that nice on Java 8. That's pretty cool. So if we do that, then probably that's not going to serve anything anymore. That's correct, because we've just changed the way the identifiers look, right? And then we go here, and that should serve the same thing. You see, we've just like changed the way the URIs look, and everything else is basically just like working the same. Something slightly similar, but also very different is the following thing. And it's actually also picking up on something that I mentioned in the talk yesterday. Unfortunately, I always mention JPA because it has this entity annotation. Unfortunately, the DDD concept of an entity or the DDD concept of a value object doesn't like really map or transfer one-to-one into persistence mechanisms. Let me give you an example here. We have products, or we have line items, and these line items have a certain type, right? And let's say we have a dedicated set of allowed line item types, right? There's like 2 or 3 that make sense from a business point of view, but you have the requirement that they must not be hard-coded, so they can't be an enum. They must be maintained in a database, right? And like conceptually, that line item type is some kind of a value object, because let's say I think I create some of them in the bootstrap of the application. Oh yeah, just line item type product. Let's say there's another line item that's just some kind of discount or what have you, right? So you basically have this kind of finite set, like virtually finite set of elements here. They sort of conceptually are a value object, but due to the fact that you have to store them in the database, and in this case here, we're using JPA, they need to become an entity, and JPA entity, which they are actually not, like in terms of DDD entity, because the line item type product is just the line item type product, right? What's the problem with that? And let's have a look in here, in this case, the orders resource. Is it that? Yeah. There we go. Where is it? Items, product, type product. Oh my God, I think, yeah, I've already enabled it, right? Damn it. I ruined the trick. I'm sorry for that. Come on. There you go. Right. So you see there's this list of line items here. And there were 2 aspects. So the first thing was I had to make the line item type an entity, although I didn't really want to. And the second thing is because I of course have to manage those line item types. I have to create them. Once every 10 years, I have to add a new one. There's a line item repository in the system, which then even makes the line item, the type, an aggregate, like according to the way that Spring Data REST works. And that, in consequence, means that this thing is linked to. Blah, puke, right? So now instead of that really nice short string, like the name, product, or a discount, or what have you, we get a link relation to something separate, and then that's pretty inconvenient for the client. So what we actually do here is we define another entity lookup, and then declare a repository to be a value repository, which basically means, okay, dear Spring Data REST, go ahead. This repository is not really making up an aggregate or turning an entity into an aggregate, but it's actually serving values, right? And by the way, we want to use that property of that class to show up in the representations that are referring to them, And again, we have this mapping step back to find the actual value. And then that basically turns that thing into that. That might not look that impressive in the first place. It unfortunately still requires quite a lot of Jackson Kung Fu to actually get that right, because on a put request, we now have to take this string and basically replace or load the actual type object from the database and then hand that to the actual object instance. So that this works. But assume another good example for that is like if you have let's say addresses and they're supposed to be, you have to add a country to that address, right? And you want to manage the list of countries that are available for selection. Then you again have probably those in a database, and you want to add maybe every 10 or 15 years add a country. And then still you don't want to have these links in there just because you have a repository in here. All right, so that's basically the projections thing. I think we have URI customizations, lookup types. That's what we had already. Conditional requests. I'm going to skip those because we have like 20 minutes left. Let's speak about integrating custom functionality into an API. Custom implementation integration. There it is. Okay, how do we do that? The example that I want to discuss, and I already discussed in the other talk yesterday, with slightly different aspects, is the RESTbox example. There is a book called, which one is it? They all are so, the titles of those books are all so the same. It's RESTful Web APIs, is it that from O'Reilly, the one with? REST in Practice. Oh, I'm sorry, I got it wrong. Thanks for that. REST in Practice, it basically is all about hypermedia in REST APIs. It has this example of this Starbucks coffee ordering experience where you basically place an order. It's in a certain state of, like in this case, payment expected. While it's in that state, you can update the order, you can cancel it, or step 4 is you can just actually pay for it. The payment triggers a server-side process, a long-running process preparing the drink, and then it's ready at some point and it's going to be completed. And I like the example quite a bit because it has a couple of things in there that are quite hard to implement if you're not using a hypermedia-based approach. And they actually, on the other hand, it's not as simple as like other examples because like all this kind of server-side processing, you need to poll for a result and stuff like that. It's kind of like stuff that you find in other or in real-world scenarios as well that go beyond like a simple example. But the point that I'm trying to get to is that I've wondered, okay, which of the parts, because there's this implementation called Spring RESTbox that I have in my GitHub repo, and when I started it, I was kind of wondering, that would be, I mean, it would be a cool showcase to just like build the very same sample. They're using JAX-RS in the book. It would be a cool showcase to have a Spring-based implementation of that, just like to showcase all our tech stack. Back in the days with Spring 4 and like the first Spring Boot prototypes came up, and also like you showcasing Spring Data and Spring Data REST and yada yada yada. So the question came up, which parts of that API should actually be implemented with Spring Data REST back in the days? And it turns out like just like placing the orders and placing an order, updating it, and all that kind of stuff. That's actually kind of a nice fit for the way that Spring Data works, Spring Data REST works. However, the payment processing and all that kind of server-side like process triggering and yada yada yada, that's not really as simple as like just a post request on and then storing something in the database, right? So I thought, okay, then just let's split up these two things. They seem to be like conceptually separate anyway. And then see how we can like make Spring Data REST or build Spring Data REST in a way. And there was actually a time when a lot of these customization APIs were introduced, can be customized so that we are somehow able to plug our custom MVC controllers into that into that API space, and by that, basically letting the client be unaware that there's like sort of two different implementations here, because they just like naturally look the same, or it's just links between different things between the different styles in the code base. Let's start with like just assuming, okay, we need to polish, or not to polish, we need to place an order. So we send a post request to that, and that's something that Spring Data REST handles out of the box, right? So we have this order. Again, there's like a tiny domain model. It's nothing really fancy. The order has line items, yada, yada, yada. It's basically a one-to-one thing taken from the book. So we have an order repository here. That's in here. That's just like, the same way it actually worked before. You've known all that. The point is that, or interestingly, the thing we have to look at, the first requirements we have is that we can only cancel the order. That's what the flowchart here says. We can only cancel order if the order is in a certain state. So we have to basically teach Spring Data REST that it must not allow delete requests when the order is not in the payment expected state anymore, right? So how do you basically, the question is, how do you actually handle or tell Spring Data REST to customize that? And the first thing that is that's actually pretty easy, is to implement a repository, abstract repository event listener, because Spring Data REST throws events for like the domain objects and invokes those methods basically in its lifecycle. So when it receives in this case, the delete request, you basically get the completely marshaled object and then on before delete. And I can, in this case, go ahead and like check the state of that entity and then just like throw the exception. And that just has at response status annotation, just like that's fundamental. That's just like Spring MVC functionality basically here saying, okay, that method is not allowed, right? So we basically cut off the delete method in case the order is paid already. And that's again, coming back to the very beginning of the talk, it's like, okay, this is not like, you're never gonna get to that point if you're just like thinking about your code or your API in terms of CRUD operations, because now you basically say, okay, we have this certain business requirement that in a certain state something must not be allowed or must not actually work, and that's not something you can really express or model nicely if you're just like thinking of it as CRUD here, right? So you basically you're free to, you don't have to take care of like all the posts and all the handling of the delete request. You just like plug in the thing that's like special to your domain, in this case, that thing here. The other aspect that I have in this graphic is basically there's the state transitions 2 and 4. One is the 2 and 3 in the first place. So in the payment expected state, you're allowed to actually cancel the order and you are allowed to update the order. And hypermedia best practice or good practice is to advertise these state transitions by including links into the representation, because that way I can actually write a client that basically shows the cancel order button whenever the cancel link is present, right? Again, also stuff that I've discussed in detail yesterday. But how do I actually, I mean, we haven't seen any custom links. All the links that we've seen so far in the representation were actually generated by Spring Data REST itself. But you can write a so-called resource processor. And that allows you to like customize the resource. And it's basically saying, okay, dear Spring Data REST, whenever you render a resource of order, so basically an individual order, then give me the resource that's basically a Spring HEADUS API. So it's a representation model class, but it's not the resource, but just imagine resource processor of representation model of order, then people make fun of Java enough. So you basically get that thing, you can consume the order, and then I go ahead and add a couple of links to that, basically saying, okay, here's the cancel link and the update link, right? So that's basically in here. So we just like add certain links. So we basically managed to now implement like the cancel part of things. So by advertising the link or the state transition and preventing it from being canceled in any other state. The last part that actually now becomes the most important one is how do we actually, I mean, there has to be a resource that takes a request to trigger the payment. And we actually have to advertise that that state transition, right? So coming back here, you see that I usually like to structure my packages in a way that they're very slice oriented. So I usually have or stopped using layer packages to some degree. I mean, the web stuff is still there, but anyway. So what I basically did in the first place, I implemented like all the payment logic in a just like wrote Java code for it, right? Not even thinking about the API in the first place or the RESTful API in the first place. So we have this, my gosh. We have this service here that can actually, where you pay for an order, that takes a credit card number and that gives you back a credit card payment. You can look up a payment for an individual order, and we can take the receipt, but that's not too important here. And that's just like arbitrary Java code. That's like the just like business logic basically. And I went ahead to build to write a Spring MVC controller for that. That exposes a couple of resources. So right, it's basically blending into the URI space of orders. It opens up the order/ID so that we get the order, and then adds the /payment. So it's virtually it's like /payment, right? It depends that. And then I basically went ahead and okay, what request method do I want? I need, okay, it's got to be idempotent, so I can just like use put, and then I issue the payment service, and then I create a payment resource because that contains the data of the payment information basically. So create this class here, yada yada yada. So it's really completely manual Spring MVC controller for my custom logic. It doesn't know anything about Spring Data REST really. Well, at one point it's adding some links, but it's Spring Data domain class converter. I'd have to look at why it's using that. But anyway, the point you should get is, okay, you have this separate thing where you implement all the custom stuff that you want to put in there. So now the crucial question actually is, how do we actually integrate? I mean, we have these new resources, but we need to sort of make sure that the client actually sees the link to these new resources. And you've seen the mechanism already, because we just go ahead and register yet another resource processor that basically says, okay, if the order is not paid yet, just add the link to the payment resource. I've just like introduced an indirection here to use them from a couple of places, but at the same time, the same thing for taking the receipt, right? So by that fact, now when as long as the order is not paid yet, the payment link is added, and the client can see the payment link and follow the payment link, and by that hits a totally different part of our code base, which is actually our manually implemented code, and but that's totally not visible to the client really. It's really hidden behind the hypermedia mechanism. All right. Feel free to check out the sample. Or maybe one thing, coming back to the beginning where I was like speaking about, okay, is it bad that Spring Data REST uses the domain types directly? The example here uses a couple of modifications, and that's something that's probably worth mentioning. Don't go ahead and like tweak your domain classes just for, let's say, your serialization library. Don't change them. Don't add a default constructor if it's not necessary, right? Or in this case, I really took the time to investigate like every class. Unfortunately, we have to add those. Do we? I think we have to. Yeah, we have to add the default constructors here because JPA requires them. That's a bit unfortunate, but still, there's like a couple of things that where's the Jackson customization here? That I, in this case, for the order mixin, I basically tell Jackson, oh wait, here is a new dedicated constructor, or basically that constructor that's already present in the order class, but that's the one you're supposed to actually use for creation. I don't want to put that JSON creator class in my domain type, right? And I just like use that mixin mechanism here. Sorry. I mean, which is kind of nice because I have one single class where all that mapping is kind of in there. There's another module for to teach Jackson how to actually serialize money values, right? So that's just a bit of code in here. So keep that code separate, and then you basically still have that domain model and the mapping layer basically, but just not the way that people usually imagine it to work. Final thing here, you might have wondered, there is a payment repository here, right, which is also a Spring Data repository because, of course, all the payment needs to be stored somewhere as well. And if you've used Spring Data REST before, you might wonder, well, doesn't Spring Data REST by default actually expose HTTP resources for those repositories? Yes, it does by default, but it's considering the visibility of the types, which is kind of also a pet peeve of mine. In this case, it's just enough to make that thing package protected because you sort of indicate nobody outside that package is supposed to see that repository. So we're assuming if that's the case, then the outside world shouldn't see it either, right? There's been a ticket open that to customize that. There's I think a new API in the current Spring Data REST release where you can basically tweak the default settings because some people just didn't like that we expose like all public repositories in the first place. And I was usually explaining, well, if you don't want them to be public, then don't make them public. But I see that like in certain environments that it might be like something worthwhile to have, say, okay, only if that interface is annotated with @repository REST resource, that then it gets exposed. Anyway, just that tiny bit that people sometimes forget. Okay, that's basically it. Do you have any questions so far? One question, Edward.
Yes, I noticed you're using a couple of things that myself personally I've never used before.
Like Eclipse?
Yeah. No, I haven't used STS, but yeah, I have multiple.
No, just kidding.
No, but for instance, with Jackson, there's a lot of technical requirements that are not really known until you get comfortable with REST. Specifically, like you're showing a lot of expertise with Jackson. Like I've never seen Jackson Creator, and then moreover, like the cross-cutting concerns you did with being able to trigger the application lifecycle or the lifecycle by triggering on the REST repository, event listener. That's pretty fascinating stuff that you can get into some serious black magic. Do you know, like any best practices?
It's code, it's not black magic.
Can you like implement like AOP with that or at all?
So the question is like, can you AOP with that? Yeah, it's, I'm trying to digest what the actual question is, to be honest.
Sorry, let me make it simple. What are the technical requirements to really become advanced in Spring Data REST?
Well, so what are the technical requirements to like really make use of like this more complicated stuff? The first thing is like just consult the reference documentation. So all the repository event listeners are in there. Like Jackson customizations is basically it's not so much, we don't have that really in the reference documentation because that usually becomes like if you see the JSON representation doesn't look like you want it to see, and you have your domain class, then there's just like usually two options. First is you change your domain class for the worse, which you should do, as I said, and then the other option that is usually the bad consequence of that is like looking in and learning all about all the different ways that you can customize Jackson stuff. I'm not sure I'd call this an achievement, being so familiar with all the different ways, because I would have had a lot of more hours for myself if I didn't have to wade into all of those. But SpringData REST is using quite a lot of sophisticated and a lot of callbacks of Jackson and a lot of serialization hooks and whatnot. The positive aspect about this is you usually can get sort of everything to work the way you want it to work. It just might require a bit of bashing and kicking of Jackson, but yeah, I mean, start with mixins. Mixins are probably the most, the first starting point. I probably wouldn't want to go into a serializer, a custom serializer in the first place. But it's basically like understanding how Jackson serialization can be customized. That's like a sort of a separate thing there. Les?
So with REST, everything should be discoverable by the client, right?
Yeah.
How does the client determine what projections are available to it?
Okay. The question is, how does the client, what projections are available? Do we have still one running here? So we serve some metadata. It's a bit of a pity that because of the lack of time, I couldn't actually get into that. And that's where the profile link comes into place. So when you follow the profile link relation, you actually you get back another HAL document that has like just links named just like the links that you find in the representation. And then, for example, what was it for the customers? You get back an ALPS document. That's like application level profile semantics standard introduced by Mike Amundsen, and there should be somewhere there should be a customer, get customers. There's a descriptor, and there's like it takes that's probably because they're ordered so weird. So you have there's a projection descriptor, and that has a value that's probably just like because of the formatting. There's one that's named excerpt, and that gives you those three properties again. So it's in there. We also serve, if you go here and say accept application schema plus JSON, then you basically get a JSON schema for the object. And that's also another interesting thing here. Do you remember all the Jackson customizations I applied? Because by default, the Jackson, if you just like inspect the object model, then you like, okay, there's an address. But if you write a custom serializer that just flattens that thing out into a string, then you also actually have to adapt your JSON schema for that. And there's some callback interfaces that allows us to do that. But that's basically the way that's implemented. There is a HAL browser that we ship with as a SpringData REST module that uses that metadata to basically provide you custom forms for all of that stuff, but that's probably a bit too far for now. All right, so I'm happy to take other questions offline, still be around until even tomorrow. Thanks for your attention. I hope you enjoyed the talk and the conference in general. Thank you very much.